Stars are fascinating objects in our universe. They are giant balls of gas that produce heat and light through the process of nuclear fusion. These objects have captured the imaginations of people for centuries and have played a significant role in the development of our understanding of the cosmos. To start, let's take a look at what makes up a star. Stars are primarily made up of hydrogen gas, which is the most abundant element in the universe. Other elements such as helium, carbon, and oxygen make up a smaller percentage of a star's composition. These elements exist in a plasma state, which means that they are stripped of their electrons and exist as charged particles. The formation of a star begins with a cloud of gas and dust called a nebula. These clouds can be found throughout our galaxy and are the birthplace of stars. As gravity causes the gas and dust in a nebula to condense, it becomes denser and hotter, eventually leading to the formation of a protostar. Once a protostar has formed, it will continue to contract under the force of gravity, causing its core to become hotter and denser. When the temperature in the core reaches around 15 million degrees Celsius, nuclear fusion begins. This process fuses hydrogen atoms together, creating helium and releasing a tremendous amount of energy in the form of heat and light. This energy creates the outward pressure that counteracts the force of gravity, keeping the star stable. The amount of energy released by the fusion process determines a star's brightness, temperature, and color. The lifespan of a star depends on its mass. Small stars, known as red dwarfs, can live for trillions of years, while massive stars may only live for a few million years. When a star runs out of fuel, it will begin to cool and contract, eventually becoming a white dwarf or a neutron star. In some cases, the star may explode in a supernova, leaving behind a black hole. In addition to their role in the formation of our universe, stars have been important throughout human history. They have guided travelers across the globe and played a significant role in the development of astronomy and navigation. Today, astronomers continue to study stars to better understand the processes that govern our universe and the origins of life on Earth. In summary, stars are giant balls of gas that produce heat and light through the process of nuclear fusion. They play a critical role in the formation and evolution of the universe and continue to capture our imaginations with their beauty and mystery. Stars are classified based on their temperature, brightness, and color, and astronomers use this classification system to better understand the characteristics and behavior of different types of stars. The most well-known classification system for stars is the Hertzsprung-Russell diagram, which plots a star's brightness against its temperature. This diagram allows astronomers to classify stars into various categories, including main sequence stars, red giants, white dwarfs, and more. Main sequence stars are the most common type of star and are located along a diagonal line on the Hertzsprung-Russell diagram. These stars, including our Sun, generate energy by fusing hydrogen into helium in their cores. As they do so, they emit light and heat that keep them stable and bright. Red giants, on the other hand, are older and cooler stars that have exhausted the hydrogen fuel in their cores. They begin to expand and cool as they fuse helium and other elements. These stars can be many times larger than our Sun, and they have a distinct reddish appearance due to their lower temperature. White dwarfs are the final stage in the life cycle of many stars. These small, dense objects are the remnants of stars that have exhausted their nuclear fuel and shed their outer layers. They are incredibly hot and luminous but do not produce energy through nuclear fusion. Finally, some massive stars end their lives in a supernova explosion, which releases an enormous amount of energy and sends matter hurtling out into space. The core of the star may collapse into a neutron star or a black hole, depending on its mass. In addition to their scientific significance, stars have also played a crucial role in human culture and mythology. People have looked to the stars for guidance and inspiration for thousands of years, and many ancient cultures built intricate calendars and observatories to track their movements. Today, we continue to study stars and use our understanding of their behavior to answer fundamental questions about the origins and evolution of the universe. From exploring the properties of individual stars to studying the formation of galaxies and the structure of the cosmos, stars remain a fascinating and vital area of research for astronomers and astrophysicists alike.